So good morning and welcome back to the class on tribology. So if you remember yesterday we were solving few problems related to plane slider bearing, right? So one more category what we need to check is how to determine the pressure distribution and to show the graph as well. So we'll be solving one problem related to that and then I'll come back to this numerical. So the fourth problem basically helps you to draw the pressure distribution, how the variation comes into picture with respect to the pressure distribution in any plane slider bearing. Around 12. So this is a problem what we need to take up. So this is a numerical. Everyone kindly take down the numerical. So it is an rectangular plane slider bearing again with fixed shoe, which has a specific details as shown here. So the length of the bearing is given to be as 80 mm. So kindly note down the length of the bearing as L equal to 80 mm. You need to convert that into meter later. Width of the bearing B is given to be as 60 mm. Please take down the value of B is equal to 60 mm. Slider velocity is given directly in meter per second, so no need to convert anything. So write down capital U, which is the slider velocity, as 2 meter per second. Then the viscosity of the lubricant is given as 0.1 Pascal second. So no need to convert. It is not given in centipoise, it is Pascal second. So directly you can substitute the value of viscosity of the lubricant as 0.1, wherein the minimum film thickness and the maximum film thickness, which is H1 and H2, is given in terms of mm. Okay, so kindly note down the value of minimum film thickness, which is H2, 0.02 mm, and maximum film thickness is H1, which is 0.0. I have written here by mistake as H2. Minimum film thickness is H2 and maximum film thickness is H1. So H1 will be 0.06 mm. So what we need to determine is you need to draw the graph to show how the pressure is varying across the length of the bearing. So length of the bearing, we know it is a distance of 80 mm, right? So with respect to the length of the bearing, how the pressure is being varied. So that we need to check into. Okay. So for that you need to know the pressure value. And this is the pressure distribution equation. The variation of the pressure across the plane slider bearing could be evaluated by this equation. So this we have derived already. So everyone note down the pressure equation, right? So P will be equal to mu capital U divided by B into 6 times of A into x1, open the bracket, 1 minus x1 divided by 2 minus alpha minus 2a, again open the bracket, it is a minus alpha plus alpha x1 whole square, right? So this is the pressure distribution equation number, and it is there in the data handbook as well. So now you have to see in this pressure distribution equation whether all the values you are aware or not. The lubricant value, the viscosity of the lubricant is given, velocity value has been given, width of the bearing is given, right? X1 is unknown, what we have to evaluate it. And even A value is not known, and also the alpha value is not known. But they have given us the minimum and the maximum oil film thickness. So with the help of H2 and H1 value, right? And the value of B is also given. So with this data, you can find out what is the inclination angle. And always remember, inclination angle should be in terms of negative, right? So alpha will be H2 minus H1 upon B, right? This equation I have already told you to how to determine the inclination angle in the previous problem. So the same equation you will write and go back to the equation and check which is H1 and H2, right? So maximum film thickness is 0.06, which is H1, and minimum film thickness is 0.02. So accordingly substitute here in the equation. So minimum film thickness is 0.02, maximum film thickness is 0.06 divided upon the width of the bearing. So width of the bearing, how much it is given here as 60 mm. So kindly substitute in the alpha equation and calculate. Everyone please check how much you are getting the value of alpha. Be quick. Kindly do calculate. How much you are getting?
Minus 6.67 into 10 power minus 4.
Okay, let me see. Yes, minus 6.67 into 10 to the power of minus 4. So now we have got the value of alpha. But to go for the pressure equation, you need to know the value of A also. So A, you know the equation already, which is H2 by B. H2 value is known, which is 0.02, and the width of the bearing is also known, which is 60. So kindly divide 0.02 divided by 60. See the value of A, how much you get. I need the answer from everyone. How much you're getting?
Ma'am, 3.33.
Yes,
Into 10 power
3.3.
minus.
10 power minus 4 you're getting, right?
Yes, ma'am.
Yeah, so once you get the value of A, so now in the equation you have x1, right? So to know what is x1, you have to use this formula. So x1 will be x upon b. Overall length, it is, if you go back to the diagram here related to the width. Okay, so this part will be x1. Okay, so this entire length is the width and remaining part will be something x. So you should be knowing exactly x1 at which the load will be maximum bearable. So at that point even the pressure will be maximum. So in terms of that, the x should be replaced with the parameters x1 and b. So that's what now we are making the changes. If you go back to our problem here, right? So you'll be writing x1 is equal to x upon b. So here x value is unknown. We will put the values x later, right? So x divided by b. So b, you know what it is exactly. It is the width of the bearing. So you will kindly write the value of b. So now you have the value of alpha with you. You have the value of a, and in place of x1 you will be writing x upon b. So b is nothing but our 60. So in place of x1 you can directly write x upon 60, and other parameters like mu, u value also you are aware. So everything you kindly substitute and you will simplify the equation, but x will be unknown. So kindly substitute to the equation here now. So you have the viscosity of the lubricant mu, which is nothing but 0.1 Pascal second. It is given directly in the question with respect to Pascal second. So don't convert it again. Directly substitute the value. So it is 0.1 into the velocity. The slider velocity is also given as 2 meter per second. So don't convert again into meter. Directly it is 2 divided by the width of the bearing. If you go back to the question, it is 60 mm. Kindly convert that into meter. So it is 60 into 10 raised to minus 3. So then open the bracket. 6 is a constant. And A value you have currently determined, it is 3.33 into 10 raised to minus 4. Kindly substitute that. And x1 we have replaced in terms of x, right? So it is x upon 60. After that, open the bracket. The equation tells it is 1 minus x1. So kindly write here 1 minus x1 value here is x upon 60. So you will write x upon 60, close the bracket. Divided by, please again come to the denominator. In denominator you have alpha. Alpha you have determined as minus 6.67 into 10 raised to minus 4. Kindly type here minus, write the value constant which is 2 into A is nothing but our 3.33 into 10 raised to minus 4. Kindly do write and close the bracket. Again open the bracket. The value of A is given as 3.33 into 10 raised to minus 4. Substitute it. Minus of alpha is, it is minus alpha, and alpha value itself is negative. So minus into minus, it will be plus. If you don't change the sign convention here, just retain minus, open the bracket and write one more minus over here. Minus, or else you can directly write plus. 6 points, minus of 6.67 into 10 raised to minus 4. Close the bracket. Plus alpha value is again minus 6.67 into 10 raised to minus 4. Into x1 will be x upon 60. So you have to substitute with respect to the equation. So later, after you have substituted, you have to simplify this little bit. So once you substitute as per the equation, just simplify this constant part. How much you get? 0.1 into 2 divided by 60 into 10 raised to minus 3. Then try to simplify this part in the numerator and I1 in the denominator. And please let me know what is the simplification part you will be getting. I will just share my screen. Just see whether you get this part as shown here. So after the substitution, right? So this part you will simplify. 0.1 into 2 divided by 16 to 10 raised to minus 3. You have to get somewhere around 3.33. Okay. So then again in the numerator, this part you will simplify. 6 into 3.33 into 10 raised to minus 4 into x upon 60 with this constant, with the parameter of x. So you will get somewhere like 3.33 into 10 raised to minus 5 into 1 minus x upon 60. So this will be your numerator. Similarly, denominator part, this entire thing you have to simplify. All these are known values. Only this is the x term which is unknown. All these are known values. You will simplify it. And the denominator should end up with 1.33 into 10 raised to minus 3. Again 1.1 into 10 raised to minus 3. Minus of 1.1 into 10 raised to minus 5 x whole square. So this is how it ends with respect to x. Okay. So if it takes time for you to simplify, kindly take down. This is how it has to end, right? After this, I will let you know what to do. Are you simplifying or are you just taking down? Kindly reply, let me know what you people are doing. Are you people trying to simplify?
Yes, ma'am.
Yeah. Did you people simplify it? Any order, if you end up also anyhow, you will get the value of p when you substitute for the value of x. It's not like this is the end where you have to stop it. Just try your level best to simplify in the simplest form so that later we can try to figure out the values of pressure.
Ma'am, in numerator there should be another x number.
In the numerator another x, you're telling. Yes, we have x here. You're telling about x square?
Eh, like
Or you're getting what you're.
3.33, ma'am, 3.33 into 10 power minus 5x into 1 minus x by 60.
Okay, I have missed out one character here. Hope you are done it properly, na?
Yes, ma'am, yes, ma'am.
Okay, thank you for your correction. So there should be one more x. And what about the denominator?
Correct, ma'am.
Okay. So once you have got this, what in the question they have asked is draw the graph of variation of pressure along the length of the bearing, right? So now we don't know what is the values of P. So this P will get varied with respect to the values of X, what we will be giving, right? So this X you have to keep on varying. So now I have explained you in derivation of maximum load bearing capacity equation, right? So at the pressure where it is maximum, you will be having the maximum load bearing capacity. So the entire width of the bearing is somewhere around 60 mm. So you can just figure out some values of x until 60. So you can take, if you have more time, you can take of like 2 or 3 divisions, right? In with respect to 3 division interval, you can go on until 60. Yeah, with 2 division interval, you can go on around until 60. Yeah, with 5 values of interval, you can go around until 60. So I've shown here only until 50. You can make it like 55 and 60. So that will be the entire length of the bearing where the value of x keep on varying. So now in this equation, when you decide the intervals for the values of x, if we are taking as 5, 10, 15, 20, 25, 35, 45, whatever, so you have to substitute in this equation the values of x, like f x is 5, x is 10, x is 50, x is 20, 25, 30, 35, 40, 45, 50, 55 and 60. For different values of x, you will get different values of pressure. Because this is the pressure equation what we are using, you will get different values of pressure. Once you get different values of pressure, for the values of x, you have to take the graph sheet, take the values of x along your x-axis and values of p what you have obtained along the y-axis. Then you try to draw the graph. At some particular point, you will be having the maximum pressure value. So that will be the point where you will be having the maximum load bearing capacity, because the thumb rule is where the pressure is high, it can bear a maximum amount of load. So you can try this later, put different values of x and calculate the values of p, draw the graph and show. So this is the pressure distribution graph. If they ask you, you have to plot in this way. We have done this type of one numerical even in the previous module, right? So you can get even this variety of numericals also related to hydrodynamic full journal bearing. We have done it, right? So similarly, you have this type of problem in our plane slider bearing problems as well. So apart from that, the other part they have asked us, you have to determine the coefficient of friction. So coefficient of friction value you know already. The equation you are aware enough to determine the coefficient of friction. For that, you should know what is the frictional force. So the frictional force equation we have used in yesterday's class and we have derived also in previous sessions. So the same equation we'll be using as per the data handbook. It is equation number 24.103, right? So you will write down the frictional force equation, which is minus mu ul into 4 by alpha log of A minus alpha divided by A plus 6 divided by 2A minus alpha. So now all the values are known. You know the value of coefficient of friction, value of U, value of L, right? And then A and alpha value is also known. So kindly substitute all the values and please let me know what is the value you get. So in the equation, you need to check what is the value of coefficient of friction, right? So if we go back, sorry, in this they haven't asked it is just pressure distribution. Fine, then leave it. If along with this, if they ask you to determine the coefficient of friction value, you have to go and calculate the coefficient of friction. So which is nothing but F naught upon W. Okay, so for that you need to know the value of F naught, and the equation of F naught is given. So you'll kindly substitute the values and calculate the frictional force. Once you determine the frictional force, you can determine the coefficient of friction. So it is nothing but F naught by W. This type of problem we have solved already. So you will substitute the value of F naught divided by the load bearing capacity. For this, you should know the value of load. You should derive the value of W also. You have two categories of problem. One thing, they ask you to determine the frictional value, frictional force, coefficient of friction and power loss, or else they can ask you to determine the pressure distribution and draw the graph and show. But asking both together is in rare case. If they ask, you should be able to figure out the pressure distribution, draw the graph, then determine the load bearing capacity value. Okay, if they ask you pressure distribution graph, you have the chance of getting to calculate what is the maximum load bearing capacity. If they ask you to determine the maximum load bearing capacity, you should go back and use the equation for maximum load bearing capacity, what I told earlier, which is W max. So this will be maximum where you have the high pressure, right? So this we have derived already. So you have to go back to the equation W max equals to 0.1602 mu UL B square upon H2 square. So where U will be the slider velocity, this value will be known, length of the bearing will be known, width of the bearing will be known, and minimum film thickness of the oil also will be known. So you will substitute this value and calculate what is the W max. You have the chances of getting a pressure distribution graph along with determining the W max value. But apart from that, if they ask you to derive the other common things, what we usually derive, right? Like frictional force, coefficient of friction and power loss, for that also you should be ready. So now I hope how to solve the problems, these aspects are clear enough. Any doubts in solving the problem related to the pressure distribution as well as the other parameters like frictional force, coefficient of friction and power losses? Any doubts in this? I need an answer. I will give you one more numerical to solve.
No, ma'am, no, ma'am.
Is it clear? Fine. So there is one small problem wherein I haven't solved. I have just left for you guys to do it. So let me see, you can solve and let me know. So please take down the question. So it is a rectangular plane slider bearing with a fixed shoe. It has following specification. The specifications are bearing length is 90 into 10 raised to 3 meter. Okay. And bearing width is 75 into 10 raised to minus 3 meter. They have converted and given you in terms of meter already. So don't convert it again. And load on the bearing is given as W, which is 18,000 Newton. Apart from that, they have given you the inclination angle alpha. So which is minus 0.00035 radians. Okay, so along with that, the viscosity of the lubricant is given, which is 45 centipoise. So this you have to convert it in terms of Pascal second. So you have to multiply this into 10 raised to minus 3. So what you have to determine is, you have to determine the value of H2. What is H2? H2 is minimum film oil thickness. So you have to determine the minimum film oil thickness H2. So then what I have asked, to determine the coefficient of friction. So you need to determine the coefficient of friction. If you want to know the value of coefficient of friction, you should be knowing the value of frictional force and the load bearing capacity, right? So then you can determine the coefficient of friction value, and finally the power loss. So this is the thing what you have to determine. So now to determine H2, right, you need the equation. So what we usually use. So A is equal to H2 by B is the equation what we use. So H2 will be equal to B into A. So to determine H2, which is minimum oil thickness, you need to know the value of A. Even the value of A is unknown. How will you determine the value of A? Only the option is you have to go for the load bearing capacity equation, not for maximum load bearing, just the load bearing capacity equation. Why we are going for this is, in the load bearing capacity equation, we know all other parameters apart from A. Because if you cross check, you have the value of load bearing capacity value as 18,000 Newton, and even the viscosity of the lubricant is given as 45 centipoise. The velocity, the slider velocity value is also being given. What is it? Is it given? It is 645. No, the value of U, I think I have missed somewhere the value of U. So the length of the bearing is 19 to 10 raised to minus 3, and the value of U has to be given here. I think I have missed the value of U data. So I will cross check and give you this. Fine, I'll give this numerical problem and one more as an assignment with the derivation part. So you people can solve it and give me back, because here I have missed out one value of U. So I will just cross check and give the value of U. So this is about the way how to solve the problems. So you can get two trends of numericals. One, determining the value of pressure distribution, show the maximum load where it has been approaching at what particular value of pressure. The other things are to determine the load bearing capacity value, the frictional force, the coefficient of friction, right? And the power loss. So these are the two categories of the numericals what you get usually. Okay, so currently I will just, Ishant, you want to tell anything?
No, ma'am.
Okay, so let me just start up with the fifth module. So this I'll be giving as a part of your assignment. So I'll just stop this and let me discuss on the fifth module at least for 10 minutes. Have you checked what is the topic related to your fifth module in your syllabus? Hope the slides are visible. Yes or no?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay, okay. So our module 5 basically deals with bearing materials. So it is not a new topic to you all. You have studied like what are bearings, the classification of bearings, you know, and some amount of information related to bearing materials also you are aware enough. And we have solved numericals related to different categories of bearings as well. So now it is the time to look into which are the best feasible bearing materials to see that it can be very reliable for a longer run of the relative motion. For that, your module 5 speaks mainly about two sections. One is bearing material, so wherein you need to speak about the largely available bearing materials, what are its properties, and which are the key bearing materials in which you can focus and select for your applications. Finally, you should also know about what are the advantages and disadvantages of different bearing materials, so that it helps a designer to select the material before it has been manufactured. So this is the concept under bearing materials what you will be studying. So the other part in your syllabus mainly speaks about the surface engineering. You know, surface engineering plays a vital role, right, with respect to any type of journal bearing, any type of bearings which you are focusing. So you need to understand the scope and the importance of surface engineering, how you can modify the surface, so which are the heat treatments you usually perform to enhance the parameters, physical properties of the material, and also how to safeguard the surface of any device by means of surface coating. So different type of surface coatings which are usually available, so we'll be speaking about that. And finally, which is the best way of selection of an coating, so that you can reduce to some extent the wear and also the corrosion resistance with respect to the external environment. So this is the brief outline related to the module 5 what we have to GLAB, right? So let us start with respect to introduction to bearings. So you know, bearings are usually used so that it supports the moving elements or moving parts. So these parts could be like anything. For your example, I'm sorry, it could be a shaft, a spindle movement, or any type of mechanism in which you have a relative moments. You can take the help of the bearings. But before going into the material, you need to know about the classes of bearing, the bearing classifications. That also you have studied very long back. And we have focused on these two types of bearings as well. So one is the rolling contact bearing, another one is the plain bearing. So this rolling contact bearing is also known to be as ball and roller bearing as well, right? So now you have to think about in rolling contact bearings, right, which is the material usually it is made out of. So it is made up of steel that can be hardened after machining. So you have to select the grade of the steel which could be hardened after the machining process. So you have to select a proper grade of steel. There are n number of grades in selection of the steel: hardened steel directly, or a normal regular steel, a stainless steel which could be hardened after the entire machining process. So while selection, you should be very clear enough. Apart from that, you can also go for plain carbon and alloy based steels, so which will be having nickel, chromium in its combination. So these combination will go hand in hand with respect to different applications. So it is not necessary that always you have to go with carbon and alloy combination only. It depends upon what is the need basically. Okay, so with respect to that, we have different sections of the materials which are mainly meant for bearing. So which are the main types of materials which are used in very common for bearing materials are Babbitt metals. So instead of lead or tin based alloys, Babbitt metal is the most common word which has been used. Okay, so this Babbitt metals usually contain lead or tin based alloys. If it is of lead based alloys, it will be toxic and it will be harmful for the environment. But still, this wasn't used in very common large scale over the last many decades. Okay, so apart from that, the alternative materials which are available are: one is related to cadmium based alloys, second is related to aluminum based alloys, third is related to copper based, and fourth is silver based alloys, and lastly we have non-metallic type of bearing materials. So here, one as a designer has to select the material based on the application for which they are using. So based on the requirement, based on the functional properties, you have to go in selection of the bearing materials, right? So in that, we are currently going with the first one, which is the lead or tin based alloy, which is also called as Babbitt metals. So here I told you it is lead or tin based alloys, but what is the combination of alloys you have in this? Okay, so here you can see that if you go with high tin alloys, in this you will be having 80% of tin and very negligible, like around 20% of lead. If you are going like 90 to 95% of tin, so then the amount of lead content in it will be very negligible, so that it will not be harmful for the external surrounding and to human mankind. But there is also another alternative in which you have the combination of high lead alloys. So in this, maximum percentage of the content will be about lead, and only the remaining part will be of combination of tin. In this case, it will be really toxic to the environment. So you have to think about which is the possible percentage which will be feasible for the required application without harming the external surroundings. So these are the available combinations. Okay, but even you can fine tune, you can play with the materials, do trial and error, see the combinations by varying the tin and lead, and see how best material with good properties you will be getting. So this is like doing experimenting and optimizing the combination of lead and tin in the Babbitt metals, right? So as per that, you can vary the combination. So if you have a high content of lead, you call that as a lead based alloy. If you have high content of tin, then you will call that as a tin based alloy. So this classification and bifurcation you have to be aware of. By looking into the combination, you can tell whether it is a lead based alloy or it is a tin based alloy. So I'll just complete one type of alloy, so then I will take the attendance. So you have to just see the features of lead based alloys, how it will be. Okay, so if you take lead based alloys wherein the lead content is more, so these type of alloys will be very soft and it will be brittle in nature when we compare that to the tough tin based alloy. So based on the requirement, you have to select. The second main important feature is if you go with lead based alloys, it will be cheaper than that of the tin based alloys. That is the second point. Third one, the tin based alloys usually will have the low coefficient of friction when you compare that with that of the lead based alloy. So ultimately our like requirement is the coefficient of friction should be down. So in that aspect also, if you go, the tin based alloys will be more better. And secondly, the lead based alloys are toxic even though it is cheaper, right? So you should know how to select the material. And next feature is lead based alloys are suitable for light and medium loads. Okay, so it will be suitable where you need a light weight and a medium load bearing type of type of bearings, wherein tin based alloys are preferred for higher loads and higher speed, right? In this way also the tin based alloys will be more good. And lastly, if you go with tin based alloys, you can find applications in engines, steam turbines, but wherein if you go with lead based alloys, it could be used in railroad, in freight cars, etc. So these are the features of lead based alloys with respect to the tin based alloys. And as a result, you can try to focus on more tin based alloys rather than lead based alloys, right? And solidification temperature, if you go for lead based alloys, is approximately 222 degrees Celsius. Means if you think about making an bearing using this tin based alloys, you should see that the temperature should not go higher than 222. It should not be near to 222 also. It gets melted up because the solidification temperature is near to it. And hence the upper limit you can go only nearly to 180 degrees Celsius or so, so that the bearing material will be safeguarded from the temperature effects. Similarly, if you go with lead based alloys, the temperature upper limit is 240 degrees Celsius. In this case, you can go until a temperature of 200 degrees Celsius for the safer side. So these are the approximation values. Apart from all these things, what are the other common features related to these type of alloys are, it will be having a good ability to embed dirt into it. So it will be very comfortable material to the journal. Okay, and it has a very good feature of having a good resistance to corrosion with respect to external environment, whether it could be tin based or lead based, both has a good corrosion resistant feature, right? And it also has a very good seizure resistance. So these are in common the features of lead and tin based alloys. So based on the requirement, you can select which type of material is feasible enough for your bearing design. So this is one classification. So remaining part I will be taking care in the next class. So the other classifications what we dealt, right? So we have done with lead or tin based alloys. The rest like cadmium based, aluminium based, copper based, silver and non-metallic based bearing, we will be going in the next class. So now if you have any doubts, you can kindly do ask in. I'll just call up the attendance. Everyone type your name and USN in your chat room. Today is 10th. Akhil KV. Akhil? I think is absent. Anil Kumar? Anil Kumar is absent. Ankesh Aman? Ankesh? Gautam Krishna?
Yes, ma'am.
Balaji VR? Balaji VR is absent. Beldar Mohammed? Beldar Mohammed is absent. Chaitanya?
Present, ma'am.
Chetan Kumar?
Present, ma'am.
Dheeraj?
Yes, ma'am.
Ishant?
Yes, ma'am.
Harshit? Harshit is absent. Himanka? Himanka?
Present, ma'am.
Okay. Kanishka? Kanishka is again absent. He'll come once in an occasion and leave. Naga Murali Krishna?
Present, ma'am.
Kunal Raj?
Present, ma'am.
Mohammad Ayan? Mohammad Ayan? Absent. Mohammad Junaid?
Dhanush, 25.
Danush, this is your first class. What happened?
No, ma'am. I've attended many classes.
No, M Danush, right?
Yes.
I am telling you this is sorry. One more class you have attended. This is your second class. That's all. What is the reason?
No, ma'am. I've been attending.
Don't lie. I usually call your name and never I get a response. This is the second time you are answering. If you have any genuine reason, kindly call and let me know later. But see that getting attendance will be very difficult. You have an examination, final examination, what you have to write, and you need the minimum attendance. Be careful. Don't say that you were attending. Don't lie. Any reason, tell me frankly.
Okay, fine, ma'am. I'll text you.
Yeah. Mohammad Ayan? Absent. Mohammad Junaid? Mohammad Junaid is also absent. Shri Prasad?
Yes, ma'am.
Niharika?
Present, ma'am.
Nihar Venkat Sai?
Yes, ma'am.
Nikhil?
Yes, ma'am.
Nirab?
Yes, ma'am.
Prajwal? Prajwal is absent. Rishabh?
Present, ma'am.
Rohan?
Present, ma'am.
Roshan? Suman Sagar? Suman Sagar?
Ma'am, Rohan present.
Yeah, Rohan, I have given the attendance. Suman Sagar?
Ma'am, Rohan present, ma'am. 42.
Yeah, I have given the attendance. Suman Sagar? Suman Sagar? Absent. Sagar Dutt Mathur?
Yes, ma'am.
Sagar GV?
Present, ma'am.
Sanjay Raghav?
Present, ma'am.
Shobit?
Present, ma'am.
Siddharth? I don't know what happened. Siddharth is again continuously absent. Siddharth Sridhar?
Yes, ma'am.
Why you were absent in the last class?
I wasn't at home, ma'am.
Subramanya, attend regularly. Subramanya?
Present, ma'am.
Tirumana Sethi Rohan. Rohan, absent. Ullas,
Present, ma'am.
Vidyan,
Yes, ma'am.
Varun, Varun, absent. Pavan,
Present, ma'am.
Danush, 16ME64. Danush is absent. Dhyanesh Kumar, Dhyanesh, Gunasagar,
Present,
Gunasagar,
ma'am.
okay. Meghanatha,
Present, ma'am.
yeah. Meghanatha present. Rasik Baran, Rasik absent. Shiva Krishna is absent. Shreyas,
Yes, ma'am. Yes, ma'am.
okay.
Present, ma'am.
Shiva Krishna is there. What about Shreyas?
Yes, ma'am.
Shreyas is absent. Srinivasalu is
Yes, ma'am.
absent. You're present? Okay.
Yes, ma'am.
Yogananda?
Present, ma'am.
Okay. Kiran? Absent. Ranveer Singh Chauhan? Ranveer Singh is absent. Gautam Sai? Absent. Abdul Khalid Pasha?
Present, ma'am.
Shiv Pawan? Yeah. Shiv Pawan?
Ma'am.
Okay. And Alok?
Yes, ma'am.
Okay.
Ma'am, I was present the previous two classes. I couldn't answer.
I have given the attendance for the last class. Last to last class, you were marked absent.
That's
Ma'am,
what, ma'am.
even
My
me, ma'am.
laptop
Abdul,
hung. I
yesterday I
couldn't.
was present, ma'am, but I couldn't answer yesterday, ma'am.
No, Abdul, I've seen you yesterday. You were not there.
Ma'am, you can check, ma'am. I've logged in, ma'am. I was there in entire class, but I couldn't answer, ma'am. There was an internet issue, ma'am, yesterday. I tried to text you, but I couldn't, ma'am.
Let me check the login time and I'll mark you the attendance,
Yes,
Abdul.
ma'am. Yes, ma'am. Okay, ma'am.
Yeah, fine. Okay, then take care, everyone. Have
Ma'am,
a
have
good
you
day.
marked me present, ma'am?
I have marked you present, Alok.
The previous class, ma'am.
Yes.
Okay, thank you, ma'am.
Yes, okay. Thank you and have a good day. Bye-bye.